Hello everyone, welcome back, JavaMentor.net here. In today's video, let's learn about lambdas and functional interfaces. So first of all, I created one very simple program. I created a list of persons. I added two persons there. And then I wanted to filter only the persons that are eligible for visa and add those eligible for visa persons inside new visa eligible persons, right? And for that purpose, I created one method is visa eligible. So if person is older than 18 and younger than 50 and fluent in language, then they are eligible for visa. I added two characters from telenovela from 20 years ago, Cassandra and her partner Ignacio. So she will be eligible for visa and Ignacio will not come because he is not fluent in language. Okay, now in Java 8 they added some new things that you can use to solve this problem. So this code will be shorter. Here we solved this problem in a traditional fashion using for loop and then using if statement. But in Java 8 there is something that is called lambda. So let's just for a second think a bit. We have a logic where we are asking, is this person eligible for visa? So input is the person and output is true, false, right? So we need some function that will transform person to Boolean. So you give the data about person and you get either true or false, eligible or not eligible for visa. We can do that like this. Function. We want to transform person into Boolean. Let's call it function. And then we can say person, that is the input, then this arrow, and then the method of the body where we basically copy paste this, right? We want to say return. We only want to say, oops, person.getAge, person.getAge, and person. And this is our function that is transforming person, that is the input parameter on the left side of the arrow, and this is the body, method body, on the right side of the arrow, and inside we have some logic. Okay, now let's see how to use this function. We can say function dot apply, and then we need to pass one person. To which person to apply this function? Well, let's say first person from our list, and then the result is Boolean first person eligible equals to this. So this function will calculate is the first person from the list eligible for visa. Now this looks very clumsy and ugly, I agree. In the next video we will learn about Java streams and this will make much more sense. In this video we are learning about lambdas, which are those things, and we will learn about functional interfaces. Let's continue about lambdas. Lambda has three parts: input parameters, arrow, and body. So in our example, this is one input parameter, this is the arrow, and this is the body. So we are trying to convert person to Boolean to see is this person eligible for visa. But we can do other things. We can convert person to integer, right? And then in that example we want to do something like this. Person.getAge, let's say. Why am I saying this? Well, that's because this function interface, this is interface as you can see, and it's marked with this functional interface, is very general. It can transform something to something, input to output. But there are more specific interfaces. So let's get back to our first use case, person to boolean. There is a more specific function for this, and it's called predicate. And if you take a look at generics here, it only needs one. We can say person. If we go there, you will see that there is some input t, and it always returns boolean. It will test this input and it will give you true false result. So this predicate is transforming something to boolean, and in that fashion it's very specific. So you can obviously see that we want to do something like this. Yeah, function 2, let's say. And okay, now if you go here, let's say control click, and inside this package Java util function, you can find all of those new functional interfaces that are coming with Java 8. So let's say this int function, this is the function that is converting int to some object. Then, I don't know, consumer, you pass some object and this will do, it will not return you nothing, but it will do something. It will consume this object, and so on and so on. B function is very interesting. You pass two inputs and you will get a result. B function, then you need to specify first input parameter, let's say person, another is integer, and the result is, I don't know, boolean, whatever. B function, and then if you say control space, you'll see something like this. And then you can do logic, like if, I don't know, person is visa eligible and, I don't know, like integer is greater than 5, then return 10. This is some stupid logic, just I'm showing you. Otherwise return 15. You can do whatever you like here. Sorry, you cannot return numbers, you need to return boolean. So return true, otherwise return false. But the point is, you can manipulate those two inputs and you need to return boolean output. Now, the difference between this and this is that, as you can see on the left side here, you have those arrows around parameters. So if you have one parameter, you can omit arrows, but you can put them as well. It's not mandatory. But if you have multiple arguments, multiple inputs to the functional interface, then you cannot omit those things. It will complain. In the same fashion is right side. So as you can see here, this is gray. If you click Windows Alt Enter, replace with expression lambda, you can do something like this. So if you only have one line in the body, you can omit those things, those brackets. But if you have multiple lines, like if we have here, then you cannot omit brackets. If you omit brackets, it will complain. I saw that I have a lapsus. Those are brackets, not arrows. And just the last thing to notice is if you omit those brackets for the body, you don't have a return here. You see? Here, with brackets, you have a return, but without brackets, you don't have a return. And the last important thing to notice is that every functional interface of those predicate, function, be function, int binary operator, and so on, they have exactly one abstract method, exactly one. So they don't have 0, no 2, exactly one abstract method. You see there is a method, another method here, but it's not abstract, it has body. And also all functional interfaces are annotated with those functional interface annotations. So I created our own function. As you can see, it's not annotated with functional interface, and that's not mandatory. If you take a look, we can use our function, but if we add another method here, let's say sum1, another abstract method, everything will be fine, except that here it won't compile. So you cannot create lambdas from interfaces that are not functional interfaces. And functional interface has only one abstract method, and this interface that we created now has two abstract methods. If we put functional interface annotation here, you will see that even here we will have compile problems. So this functional interface annotation is helping us to catch the problem way sooner. So even in this interface, we see that something is wrong. It's telling us multiple non-overriding abstract methods found in interface blah blah blah. Now if we delete this one, this is not read anymore, it compiles now, and here it's compiling. That's everything regarding functional interfaces. In the next video, let's apply those functions to solve our original problems, and in the next video we will use Java streams and we will not use traditional for loop. See you in the next video.